Machine learning is often quite an inscrutable topic to fully understand for those people who aren't really fully aware of it. Machine learning algorithms usually give sometimes binary decisions, a yes or no answer, and that can be very difficult for people who receive a no answer and want to know more about what led to that answer and what can lead to that answer becoming a yes. So we worked on the FACET MQP throughout this last academic year, which looks to increase machine learning and AI understandability and readability by the common person. So specifically, we built a user interface for the FACET model, which was developed by a PhD student here at WPI. So basically, this model, when given a prediction, produced different explanations for the given user, and to explain how their application was either rejected or accepted. And what we did is made a user interface to show why their application was rejected and ways they can change the values they put for their application to be accepted in the future. So, Kate, would you like to explain a little bit more about the actual UI?
Absolutely. So with our particular project, we focused on two UI interfaces. So we first have the application selection, and then we have the main menu. And how it basically works is we first have the application selection, and that's less for users and more so for testing, because we have an automatic you can automatically select an application with preset configurations, and then that will lead you into the main menu, which is broken off into 6 main features. We first start off with the feature control, which consists of a list with corresponding values, locking icons, arrows to change value ranks, and a user-friendly manual input. So that allows for users to overall see the different types of features that they have for the preset scenario or application, and they can adjust that accordingly for ranking. They can lock in the feature into the user control to prevent moving it up or down, as well as the lock. And then we also have My Application, which more so displays all of the necessary applications, all the necessary values, explanations, and suggestions that overall gives the user a clear explanation as to why their scenario, for this case a bank application, would be denied. So they can look at the suggestions and see why exactly their application was rejected and change those based on the explanation. And we have a scenarios tab up here, which is you can create different scenarios. Say you have you change your loan application, but you want to actually change your loan term or your co-applicant income. You can make a new scenario and change it off from there.
Which leads us into the back-end implementation of our project. So when the model first starts up, the server needs to be initialized. This is where FACET first gets loaded, gets trained on the data, gets passed in all the important parameters that we want to use from an easily human-readable file. That way people who may not be experienced in programming can still style and tailor the UI to any dataset, not necessarily just a loan dataset. After this is initialized and loaded, it starts to communicate with both FACET and the front end through JSON objects. The UI will first query FACET for whether or not was this accepted. That gets sent to the backend, gets stripped of all semantic information like units or any decorative syntax. That way it's just numbers and more universal, which then gets pumped into FACET. FACET will say, oops, this got rejected. Here's what you can do. That then gets sent back as a JSON Python dictionary rather, then gets converted to a JSON object and gets sent to the front end. Here, the user can specify their feature constraints using the feature controls, which then get converted into a vector of tuples with the ranges for the constraints. This gets turned into another JSON object, gets sent to the backend, stripped of all the semantic information along the way, which then gets sent to FACET. FACET takes into consideration the new constraints the user just gave to give more explanations tailored to the user's constraints.
Yeah, so our research here is very critical in a future that's developing to more of a presence of machine learning and AI. It's very critical for both the user's end, who gets to kind of see the explanations and where their current stance is on algorithms such as this and see what they need to improve on. It's also great from the other perspective of the actual owner and runner of a system like this, such that they can help users put their best foot forward in submitting applications and using algorithms such like this. So we hope that our research and progress on this project over the last year leads to some more future developments and better implementation of explainable AI systems in the future.